We're going to be talking about Chapter 1, starting out on Chapter 1 in Section 1.1. In your textbook, we're using the Algebra Trigonometry Blitzer 4th edition. The graphs and graphing utilities is what 1.1 is about. And basically we're going to talk about a little bit about Cartesian coordinates and points in ordered pairs. And a point on a graph can be expressed with this following notation. Let's say that we have a point 2 units in the right direction from the origin and 3 units higher than the origin, and we would express this point as an ordered pair as 2, 3. And so on a graph we would actually put our x and y coordinates, and we would come 2 over on the x and 3 up on the y, so that point right there would be 2, 3. Now we could put a point, say, back 3 on the y and down 3 on the y and the x. So this point here would be -3, -3 as an ordered pair. And you may be familiar with this. You've probably seen this before in prior classes, but I just want to introduce that to you on what an ordered pair is. The first number is always the x. The second number is always the y. So how do we use these ordered pairs to graph, say, an equation? Well, I've got a couple equations here, and that's exactly what we're going to do. So I've got y equals 7 minus 2x. So what we're going to do is pick some values for x, and I'm going to just start out with maybe -3, -2, -1, 0, 1, and 2, just to pick some points. And then as I plug those values in for x, I'm going to find out what y is equal to. So if I put in a -3, I get -3 times -2, which gives me +6. So 7 plus 6 gives me 13. And if I do that for each one of these, I'll find out when I put in a -2 for x, I get 11. -1, I get a 9. I get 7 when I plug in 0. And I get 5 and 1, or 3, I'm sorry, if I plug in a 2. So, as ordered pairs, this would be -3, 13, -2, 11. These are points that would fall on our equation if we were to graph them. So, maybe down here, I'll do a quick sketch of them. Okay, so on our x-axis here, I'm going to need to come out at least a few in each direction on the x. And notice I have to come up quite high on the y. I need to come up as high as 13. So it didn't quite make my y-axis high enough to cover all those. But so -3 would be down -3 units on the x, and then up 13, so we get a point up here. And then -2, 11, something right there. And then -1, 9, roughly right there. And then it's 7, right there. And then 1, 5, so right there. And 2, 3. And you'll notice these, actually, if you were to connect the dots here, they create a line. So this line represents the solutions for that equation. So every solution for the equation y equals 7 minus 2x would fall on that line exactly. So a graph, and you might not have ever thought about it this way before, a graph is a picture, if you want to think of it, as the solutions of an equation. So all the solutions are being pictured by falling on that line. But not all graphs are lines. Let's look at our next example here, y equals 8 minus x squared. Well, here, if I pick those same points for x and plug those in, well, -3 squared is 9, and 8 minus 9 would be -1. And if we continue doing that with the values of x that we've chosen, we'll get the following numbers. And again, if these are ordered pairs, it would be these ordered pairs. Remember, the first value is always the x, second value is always the y. And if we were to sketch this, we would again see that this does not form a line. In fact, in this case, when we did -3, we got -1. So we start out here, and then at -2, we were at +4. So right here. And then at -1, we were all the way up to 7. So here, and then at 8. And then we go down to 7 again and down to 4. So if we were to connect the dots, we would see this causes a shape that looks like that. So clearly see that this is not a line. This shape is actually called a parabola, and it's opening downwards, and the line or the curve that you see here, all of the solutions for this graph would fall on that curve. So again, this is a graphical or picture representation of all the solutions for that equation. Okay, so let's move down to the next topic. And I've kind of answered this question already. What does a graph represent about an equation? Well, a graph represents the solutions. It's the solutions for the equation. And how do we graph this on our calculator? Well, that's what I'm about to show you now. You should have a TI-83 or 84. And it should look something like this. This one shows a TI-84 plus. But to graph something, we'll need to hit the y equals button. It's in the upper left-hand corner here. And you should see this screen. Well, in this screen, we want to plug in the equation. What is y equal to? So maybe we'll take our first one. Go back up here. If you remember the first graph here, we said it looked like a line going downwards, and the equation was y equals 7 minus 2x. So what we're going to plug into our calculator is under y1 is 7 minus 2x. So we type in 7 minus 2x. The x button is this button right by the green button. See, it's just to the right. It has x as the first symbol on it. It has several other symbols, but x is the one we're primarily going to use. Once we have it plugged in like this in our calculator, we want to graph it. So we hit graph. And we see there's a line coming through. And if you notice, it looks very similar to the line that we drew. So we now have a way of using our calculator to find the line. If we wanted to find certain points of the line, like the x-intercept or the y-intercept, or a certain point on the line, we will know what the y value was. That can all be found by hitting second function and trace, and you will get this screen. Value basically says tell me what x is, and I will tell you what y is. The 0, which is the second one, tells you what the x-intercepts are. 3 would give you a minimum point, 4 would tell you a maximum point over some certain range of x values, and 5 we'll be using quite a bit for intersection. So if we had two graphs at the same time, we could find an intersection. So maybe that's what we'll do next. Go back to your y equals and move down to the second function, the y2 function. In it, we're going to plug in the 8 minus x squared, which we had for our other equation. So we plug in 8 minus x, and to square it, we're going to use this symbol here, and then a 2 behind it, means to square the x. And when you graph it, you'll see that we get now our upside down parabola, or parabola facing downwards, and we have a line passing through it, and the line clearly hits it in two different locations. We can actually find those locations by hitting second, trace, go down to the intersection, hit enter, and you'll see it says first curve. Well, it's chosen the line, what we put in the y1. So since it's already chosen that, we just hit enter, and it automatically jumps to the next line, which is y2, which is the second curve that we want to look at. And then it says guess. Well, that means move the little cursor. You'll see this little cursor riding along. That means move it close to one of the intersection points. So maybe I want to find that intersection point right here. So you get it near that, and you hit enter. And you'll see it tells you the intersection point occurs at 2.4142136 and so forth. And the y is 2.1715729. So that would be the point where that line hits that parabola. If we wanted to find the second point, we would do the same steps, only when it said guess, we would move the cursor that's riding on the graph closer to the point that's higher up there, and it would find that point for us. So that's a little bit about the calculator and a little bit about 1.1, how we do graphs. By using the plotting method, we find some points and we plot them and then connect the dots. And often when we get to things, they may be related. So often we find there's a relationship between two things. Some things that might have a relationship that might be related that would be linear. Well, I would think maybe outside temperature. What would be related maybe to outside temperature? I don't know. Let's say and heat stroke. If we compare the two, we would probably see as the outside temperature gets higher and higher, more people have heat strokes. Probably would be some kind of relationship. It might not be exactly linear, but there's probably some relationship there that would probably be linear. One that's happens quite often is the amount of education and salary. You make more money the higher your education. That's been proven. That's why you guys are in a math class trying to learn math and get a higher education to make more money in your life. Another one would be time studying and grades. The more you study, the higher your grades are. The more homework you do, the more time you put into it, you will see a direct correlation in higher grades. But like I said, not everything's linear. Some things are not linear, but they're still related. One, for example, would be the speed of your car. And miles per gallon. The faster you go, friction actually drags on your car in a squared term, so it actually exponentially goes up as you go faster. So as you go faster and faster, the amount of energy required to push your car through the air goes up, so therefore you burn way more gas. Not just a linear relationship in gas, it actually is squared. As the friction goes up, it goes up as a squared term, so therefore you see way more fuel consumption the faster you drive. Let's see, another one would be the rate of compounding interest and interest earned. So the more you compound some money that you have in the bank, the interest rate does not go up linearly. It goes up on a exponential curve. So the faster you compound it, the more money you make, but it does flatten off at a certain point, but it's not linear. The area of a circle. And its radius are not a linear relationship. A 1-inch piece of pipe does not allow half the flow of a 2-inch pipe. A 2-inch piece of pipe can allow far more volume of water to pass through it than a 1-inch pipe. So if you had two 1-inch pieces of pipe, you would not be able to flow as much water through them at a certain pressure as you would a single 2-inch pipe, because the area is not linear as far as the radius going up. So that's a little bit of introduction into kind of relationships between things, linear relationships, and a little bit of non-linear relationships. 1.2 is a section on linear equations and rational equations.